Yo, Wiz, I heard that if you have one model that's really good at one task and another model that's really good at another, you can just like merge those bad boys and crush both tasks. Is that right?
I think that's pretty true. Yeah, as long as they share common architecture, that seems to be right. Yeah.
They have to share the common architecture. Okay. And we can straight up just use this tool mergekit to bang this out. No problem.
Uh, that is literally true. No
So it does
problem. Bang it out. Exactly.
it
Yes.
does exactly what it says on the tin.
Few
Mergekit.
things do what they say on the tin more than merge kit.
Love it. Love it. Love it. Okay. Well, we got a lot to cover today. Llama 3 came out last week. It's time to do some merges. We'll see you back for a couple discussions throughout before we get into the demo stuff, Wiz. My name is Dr. Greg, and that was the Wiz. We are co-founders of AI Makerspace, and today we're talking MergeKit. Shout out to rc.ai and the creator of MergeKit, Charles Goddard, who will be joining us live throughout today's event. So fire up your questions along the way that you have for Charles, that you have for us. Throw them, please, into the Slido or the YouTube live chat. Just know that we will be prioritizing the Slido questions, so go ahead and upvote those at the end. So today, we merge. And since Llama 3 came out last week, we'll be doing kind of a meta Llama 3 merge a little bit later on with two different fine-tuned versions. All right, let's go. Model merging with mergekit. And as we align ourselves to the day, we are going to walk away from this session with sort of a better idea. Why model merging? What are the kind of use cases that this is being leveraged for today? And what do we expect in the future? We'll understand conceptually the merging algorithms that kind of form the basis for the technique of merging. And we'll also spend a little bit of time fine-tuning Llama 3. We thought that was important just because it's so hot after the release last week. We just want to show you how to do a quick fine-tuning within our merge event today. And then we'll take that fine-tuned version and we'll merge it with another fine-tuned version of Llama 3, demonstrating this idea of multitask learning. So we'll talk merging first, then we'll talk mergekit and algorithms before we do some fine-tuning and some merging. The big idea of merging is simple. When we talk about merging, we're just talking about combining two or more LLMs, language models. They don't even necessarily have to be large LLMs. They could be SLMs into a single language model. And this is, again, why the architecture piece that Wiz noted is kind of important. And you might say, well, why merge? Why should we think about merging? Well, we can improve performance, especially across multiple tasks, as we'll demonstrate today. And, this is really a great way to kind of put together a lot of different capabilities into a single model. So you could imagine this being useful for enterprise in some way. We'll try to get to the bottom of exactly what that is with the help of Charles and Wiz today. And the other thing is, when we merge, it's pretty cheap. It's pretty inexpensive. Fine tuning, on the other hand, is kind of a big lift. It's kind of a lot. And so when we do fine tuning, we're often using 1,000, 10,000, 100,000 samples. When we merge, we can actually do it just very, very easily, very, very simply, even on CPU. So no additional training necessary. The other thing that's cool as we sort of stand on the shoulders of pre-trained giants and fine-tune them, what we are able to avoid a little bit with merging is we're able to sort of avoid this catastrophic interference or this catastrophic forgetting where when we learn new information, sometimes our LLMs are sort of drastically forgetting previously learned information. This isn't as much of a problem when we take an approach like merging. And as I mentioned, it's really, really straightforward to run this thing. You can do it super cheap, and that's fantastic. I want to tell you guys a little bit about some stuff that's going on, and I want to give some additional context here. The first thing is there's a lot of stuff happening in the merging space, and like what exactly it's going to be leveraged for, I don't think is very clear to the industry yet. And so RC and our friends over there are sort of running a merge-a-thon, little merge hackathon that's ongoing right now. We encourage you guys to get involved. My personal favorite is this merge that's most upsetting to the natural order, but there's best new merge, best integration with other ecosystems. And this merging technique, I heard, and I want to bring Charles up for this quick discussion as well as Wiz. I heard that this used to be called the Franken merge, and it was primarily, quote, used by hackers, not researchers, not large corporations. And it was kind of seen as this like back alley kind of dirty method. Charles, welcome. Can you speak a little bit about this? Was September 2023. Have things changed since then? And was it true?
Yeah, that's a good question. So, when this technique was introduced, it was called Frankenmerging. It was used pretty much exclusively by hackers in the open source community. Very few people in the actual research community were aware of it. That actually has changed recently. Sakana AI put out a great paper where they did some exploration of using genetic algorithms, an evolutionary approach to coming up with merge recipes, and they actually, saw this technique and said, "Hey, this is interesting. We're gonna, actually try using it." So now there are actual people who have gone to school looking at Frankenmerging, and that's very exciting to me.
So people are getting their PhDs in Frankenmerging now. Like that's pretty awesome. Okay. And Wiz, when did you start paying attention to this? When did you hear about merging, and did you hear about Frankenmerging first?
No, I think I heard about merging at about the same time as a lot of others when suddenly there was a rapid shift in the leaderboards on Hugging Face, which led to the, of course, decision to add the merged button, right, to filter them. That's when it got on my radar, and it's hard for it to have left since. Absolutely.
And maybe as before we move on, Charles, I wonder if you can comment a little bit on the LLM leaderboard merging and sort of the catalyzing of people hearing about it. And when did you kind of get into building mergekit, and did it coincide with that at all? Like, how did this come about?
Yeah, so I started building mergekit. It's hard to tell. Time is going so quickly. I want to say 7 months ago now. Basically, I read a paper about model merging. Thought it sounded cool, but there wasn't great code available, so I wrote it myself and then threw it up on GitHub. And the Open LLM leaderboard has been I feel a little bit guilty for the state of it, to be honest, because a lot of what we're seeing is that there are really real, immediate, obvious benefits to merging models. I mean, when you've got things that are trained on the same task and you merge them together, it acts as this really good regularization. You end up with just a strictly superior model. But then on top of that, when you have people seeing that they can have the number one spot on the leaderboard for a couple minutes of time, we end up with sort of just stewing in place and ending up with overfitted to these particular benchmarks. So mixed situation there.
Yeah. Oh, that's so interesting. Wasn't a solution. You started building, and it was just 7 months ago. So that was about the time that this article came out. That's when people started kind of paying attention. So very, very interesting. Well, thanks, guys. We'll have you back for the next discussion, Charles, Wiz. Really cool to get this context on merging, such an emergent phenomenon. So let's get into mergekit a little bit and the algorithms that it uses. mergekit, the tool that Charles built, is just a toolkit for merging, and it can work with Llama, with Mistral, with a bunch of other LLMs, and it's kind of a simple idea, really. And they've recently made it, since Charles joined RC, even simpler. And Wiz will demonstrate this shortly. But there's actually a GUI now that you can use that's a Hugging Face space that makes it super easy to merge. Now, you still have to be able to write some code to be able to run inference on the merged models, but the GUI really, really does streamline merging, as we'll see. And there's a few different choice algorithms that you'll hear about when you start looking at merging. The first one is linear. The linear merge, guess what it does? It is a simple averaging of the parameters, of the weights. And that's it. We take one model, take the other, average them. And it's like, this kind of works? That's crazy. It does kind of work. And, it's really easy to implement, very low compute required, because again, what are the weights? They're just floating point numbers. So we're just summing them and taking the average. But we can get a little bit more intelligent. We can look at these other methods. And as we look at one method at a time here, like spherical linear interpolation, the best way to kind of think about SLERP is that it's a slightly more intelligent linear combination of parameters and weights. It's not the simple averaging. And the idea here is that it's all about smooth interpolation. That's the S. It's spherical. It's kind of, if you imagine the entire space of weights, of vector space, we're kind of looking at the neural network in kind of this n-dimensional vector space and all of its weights. What we're doing is we're kind of, instead of using a straight line between two vectors, we're kind of getting more of a smooth interpolation between those two vectors. Because of course, if you look at an embedding space, if you use TensorFlow embedding projector, if you look at any sort of visualizable space, it often helps to spherize it and to sort of think about that thing in a bit of a round way, right? So this idea of spherical linear interpolation is at the heart of what we're doing here. But without getting into all of the vector math, it's really just kind of a slightly better way to do this averaging. Instead of just simple averaging, we're leveraging some trigonometry to make it a little bit more intelligent. And we see this theme of slightly more intelligent with each subsequent algorithm as we move through. Next, we have this trim, elect, sign, and merge algorithm, the ties algorithm, the ties merging algorithm. And it's sort of born out of this idea that there are two challenges we want to try to solve. One is that when we're merging models, some of the information is redundant. Essentially, it's the same exact weights. Why is that useful to us if we're really just trying to find what's happening between the models? And sometimes if you look at the same parameter in the same architecture, there can be a different SIGN sign, a plus or minus. And so getting rid of this sort of differences in signs and getting rid of this redundancy in model parameters is what ties merging is all about. And so rather than sort of an average or a slightly better average, here we're trying to sort of only average the parameters that really matter. Matter meaning sort of they're in the difference between the models. They're within the difference. So trim, that sort of step, is about reducing redundancy. by retaining only the most significant parameters and resetting the rest to 0. This is interesting because this idea comes up in the next algorithm we'll look at. The elect sign is exactly what you would expect. It's, okay, I have a disambiguation I need to deal with. There's a plus over here, a minus over here. Which one should I choose? Elect sign helps us resolve that conflict. And then the disjoint merge here, the merge step is just averaging after we're done with the trimming and the election of the sign. So we're looking for the stuff that's important. And kind of what's going on behind the scenes here is a bit of what's called task arithmetic. And the big idea is that you can sort of calculate the idea of a task vector if you take the fine-tuned model and you subtract out base model weights we're talking about, right? So fine-tuned model weights minus base model weights, that's kind of your task vector. Maybe you can kind of think about this in like a cute way here. If we've got kind of a sauerkraut llama and we subtract out a llama, what are we left with? We're left with like instructions for eating sauerkraut, something like that. Instruct tuned minus base. And so this is really what we're talking about when we're talking about being good at the task. That's what we want to capture. And this task vector can be used in a lot of different ways and is a bit of what's going on behind the scenes in ties merging. Finally, we have an algorithm that's not really a merging algorithm, but it sort of leverages this principle of setting the rest to 0 that we just talked about. Drops and rescales dare. This is crazy, is that you can actually drop most parameter updates within a model. That means, you know how you initialize parameters when you start training? Well, if you drop all of the updates and you go back to even up to some cases 90% of the parameters, you just go back to what they were when you started and you just keep 10%, you can actually get very good performance on specific tasks still. But there's still merging that has to be done after this step. And that's why it's a little bit different than the other 3 we looked at. Now, I took this from mergekit. Charles said as more come that catch his attention, he will work on them. And I just want to point you guys to some interesting work being done. There's a collection of model merging papers that's on Hugging Face. I would encourage everybody to check that out. And the newest paper is the evolutionary optimization of model merging recipes. And as of yesterday, RC released the evolutionary model merging. So Charles is very excited about this. We're all very excited about this. It's pretty cool. It's a little bit more guided merge versus kind of the manual exploration where you end up throwing a lot of what you do out. And so this is brand new, hot off the press. We encourage you guys to check it out. We don't have this available today in Colab, but we are going to be playing with it soon ourselves, just hot off the press. Okay, I want to bring Charles and Wiz back up, and I want to just sort of finish the why of this before we get into the how. I want to go directly to this idea of how merging is used like in real life. So if you're an organization that has been doing a lot of fine tuning over the past couple of years, and you've got sort of model over here, model over there, you got a lot of specialty models. Like Charles, the idea that you're sort of able to maybe add kind of the latest brain to your models is something that's really important. I think people think, oh, GPT-5, how am I going to leverage it? Llama 3, Llama 4, how am I going to leverage it? Do you see this as a potential use case where you can sort of easily adapt your fine-tuned models to the latest model? Is this something that's possible with merging or not so much? And have you seen any companies doing this yet?
Definitely. So I think that's a big use case for merging in a big company scenario like this. So as we are today, it's not possible to merge models that are distinct architectures, like a Mistral and a Llama model. But I'm working on that, and one day that's going to be the case. But even within that, we're in the kind of glorious situation right now where you train a model, and a week later, someone will have released something free open source that's 10 times better at the things you care about than the thing you trained. But it doesn't have to stop being useful with model merging. You can take that specific model that you trained and then combine it with whatever the new hotness is, and get all of those like instruction following capabilities and then smarts and alignment if that's what you want, and then still retain the value of what you've trained.
Okay, so this idea of like retaining the training you already did and all the compute you put into it, and then combining it somehow with the new model that came out. This is this going to be done directly through a model merge? This sort of like Llama 2 fine-tuned, let's say, merged with Llama 3? Or should we be thinking about this in a different way right now?
So that's coming. The Llama 2 Llama 3 merge is a little tricky because things changed a lot.
Yeah.
But that's going to come. Yeah.
Okay. And Wiz, I know we were talking about this earlier, like this idea of maybe using task vectors somehow to kind of maybe go from Llama 2 to Llama 3. Maybe you can clarify the question here for Charles on the actual implementation. Is that how we're going to kind of actually accomplish this?
I think what Charles is saying is that they're working on a method by which we can quote unquote upgrade the base model, right? So leverage all of the work that we did for Llama 2 and apply it somehow to Llama 3. So that's not yet something that's possible, but sounds like it's being worked on, which is pretty cool, right? But in terms of the other point that he made, I think the important thing is if you've got some new hotness that comes out for your model, right? That adds some functionality, that adds kind of something that you really want to have the capability to do. Like let's say, for instance, some really great SQL version of Llama 2, right? Comes out, and you want that capability, but you don't want to spend all this time, getting the data set, fine tuning it on top of your old model. I think this is what he's talking about when these new excellent fine tunes of your existing model come out. You can kind of merge them into your stack as you see the need to do that.
Yeah.
But they're working on that second piece, or the dream, of course, would be you can update the firmware, right? That's how we were talking about it before. Like your model is running Llama 2, and we want to upgrade to Llama 3. Not yet possible.
Yeah. Upgrading the firmware versus the software, like, the sort of base of what you did is sort of firm, and then maybe the model you're trying to merge with is kind of the soft here. Do you have any comment on that, Charles? Like, how exactly are we going to accomplish this?
Yeah. So I mean, and that's all exactly right. Thanks for that. To basically the task vectors is a decent way of thinking about this, but the issue is that when you've got these very different models like Llama 2 and Llama 3, the dimensions are all completely different. So you need a mapping there. Like you need a translation layer between what do these vectors look like for Llama 2 versus Llama 3. So we're working on an algorithm to come up with that sort of mapping automatically and be able to just take those and plop those onto a new model.
So a bit like merge adapters or something, right?
Yeah.
Yeah. Okay. Yeah. All right. So a little bit like Laura is doing, just kind of little pluggables, like, unhook this model, that model. All right. Cool. So it's on the horizon, but it's not yet possible today.
Exactly.
Okay.
What you can do today is, you can train your model on Llama 3, and then in a week when somebody releases something that's 100 times better than the official Llama instruction tune, you can get that boost in capabilities for free without having to retrain your model.
That's a perfect segue, and we're gonna be training Llama 3 up next. Thank you, Charles. Thank you, Wiz. We're gonna go ahead and jump right into the next piece of this session today, where we are going to fine tune Llama 3. So now if you want to fine tune with us, you can fine tune the 8 billion today we're going to take the instruct-tuned version off the shelf. Of course, it came out with 8 and 70. They're working on 4 hundo, so that's pretty cool. And we saw that Llama 3 has improved pre-training, 15 trillion tokens, super next level. It's crushing the other small models out there on benchmarks for what that's worth. And then they sort of are doing a lot in the post-training. Obviously, the Llama 2 paper kind of pioneered a lot of the RLHF stuff that was done, and they're still using that PPO approach here, but they're also leveraging direct preference optimization. Not surprising to see that. What we're going to do today is we're going to fine-tune our first model, and we're going to make this model able to sort of answer riddles like a champ, okay? Riddles like, sometimes I'm light, sometimes I'm dark. Most people like me. What am I? And, you know, if we can answer riddles with one fine-tuned version and do something else with another fine-tuned version, maybe we can do both of those things with the merged version. This is the idea. So we're going to take sort of Llama, not the base. We're going to take the instruct-tuned version, but this is kind of what happened between the pre-training base model and then their instruction tuning and alignment. We're going to take this, and then we're going to do some additional fine-tuning on the riddles data set to make a riddle bot for merging. So we're going to see how to do the riddle bot right now, and then we'll come right back. We'll talk about how to merge these bad boys right after this. Wiz, riddle bot time. Let's go.
Yes. Okay. Thanks, Greg. So basically what we're going to do is we're going to do some fine tuning. So we're going to fine tune 2 kind of like toy examples that are good at different, different tasks. And then we're going to eventually see what model merging can do to help us combine those tasks. So first of all, we're going to go ahead and we're going to fine tune Llama 3 on answering riddles. So we have to grab some dependencies as always. We need some data. We're going to be using a data set called Riddle Sense. Basically, it's just a data set filled with riddles and answers to riddles, easy peasy. And then that's really it, right? So we get this data set. We can see that we've got 3,500 rows with some choices, a question, and then an answer key. That's going to look like this. So we have our question, which is our riddle. Our choices are going to be labels A, B, C, D, and E. And then our text is going to be a throw, bit, gallon, mouse, hole. One of these will correctly answer the riddle. And they are most often populated with semi-confusing, answers, right? So these might fit the question in a way that is kind of correct, but doesn't adhere to the spirit of the riddle. So how are we going to actually fine tune this thing? Well, number one, we have to make sure when we're fine tuning that we're using the chat format, prompt format. So you can see here, right? Llama 3 instruct certainly has this very specific way it likes to be fed instructions. So we have, please answer the following multiple choice riddle by selecting the correct choice, only return the letter choice. We've got this, this user end header. We have a man is incarcerated in prison. As his punishment, he has to carry 1 ton bag. You get the idea, right? This is a riddle. We've wrapped it in these flags that are specific to Llama 3. And you can see this is just something that's true via their chat template. So we need these things. We want them to be in our template so that it can work properly. Okay. So we set up a template to do that in Python, and then we set up this function to create an instruction from it. So we can pass in rows of our data set, and we can get this formatted prompt with our tokens, our system header, the system message, our user header, and then the question plus the choices. And then finally, we can have as the assistant header the answer, in this case, which is E. Dope. Now we want to load our model. We're going to be training this thing using QLoRa, of course. We want to make sure we can do it with as little GPU RAM as possible. You're still going to need to use the A100 instance for this. If you follow the notebook exactly, though with some minor modification, it will run on T4, which is nice. We do need to log into the Hugging Face hub, so we're going to provide our token here. This is because Llama 3 is a gated model. You need to make sure that you accept the terms of service from Meta before you can use it. We're going to load our 4-bit quantization config here. Use double quant, NF4 for our quant type, the classics, right? Float 16 for our compute type. Pretty standard stock QLoRa setup here. And then we're going to load our model, which is just going to be from this base Meta Llama model. Nice. Okay. We're going to do some tokenizer kind of shenanigans here, right? So because we know that we're going to be training this model, we have to make sure that our padding is set to the right side and that we have a pad token. Our pad token is going to be set to the EOS token. While this might not typically be recommended due to the fact that we're using packing, it should be absolutely fine. And I'll get to what that means when we get there. So let's test the base model, right? Okay, so we have this riddle. We have some choices. Let's see what it says. It gives us the right answer. I mean, it says B, right? That is true. But it's also got all kind of this extra stuff, right? Don't really want it to give that extra stuff. Just want it to answer the question. So get to the point, right? And so we'll ask it another question, Okay, so this is a riddle. I'm black when you buy me, red when you use me. When I turn white, it's time to throw me away. What am I? We have a bunch of responses. Some of these responses could make sense, right? There are black, red, and white roses. Charcoal goes through those stages when we're burning it, and then when it's depleted. So okay, some confusing answers here, and it gets the correct answer again, but it's very verbose, lots of extra stuff that we don't care about. So what we're going to do is we're going to fine tune that all away. So just spits out the letter that is the answer. Because we're going to use LoRa, we want to set up our LoRa config here. Hilariously, we're going to do a merge step before we even get to model merging, which is to merge this adapter into the base layer, which is indicative of what is to come. So we do the fine tuning here. We're going to use the TRL library from Hugging Face to do this. We have a bunch of hyperparameters that are kind of stock basic hyperparameters. We're just going to train this thing for 4 epochs. Fairly low learning rate. Not too worried about that. Again, this example is more illustrative than it is completely useful, right? Once we have this set up, we're going to go ahead and set up our TRL trainer. We're going to limit the max length to 2048, even though Llama 3 is an 8K model, just to keep our GPU memory in check. And then we're going to pass in our Riddle data set, the create instruction function that we created above, the LoRa config that we created above, and we're going to set this packing equal to true. So packing equal to true is just a way that we can use our model's context window more efficiently, right? So each of our riddles is not that long. It's like a question and then some choices, right? So even if we really blew it out of proportion here and said that our riddles are going to be on average 500 tokens, right? Which is definitely more than they will be. What packing lets us do is instead of having one 500 token sequence and then a lot of padding tokens, so 1,500 padding tokens, instead we're just going to shove 4 examples into the same context window during training. So packing is just a way to more efficiently show the model more examples. Very handy, very useful thing to do. We are going to turn off adding special tokens and appending concat tokens. We are handling all the special tokens ourselves, so we don't need to leverage TRL to do that for us. After we do that, we call train. We train. It takes a little while, not too long, right? So 618 seconds, not bad. And then we can save our model. We're going to free up some of our GPU memory. Again, just so this works well with the T4 instance, if you change a few of the hyperparameters. We're going to load our model from that adapter, and then we're going to merge that adapter into our base model. Remember that the LoRa adapters only contain the updates to the weights. They don't actually contain the weights themselves. So when we're doing our merging with mergekit, we're going to want that full base model. So we merge it into our model, and then we push it to the hub. And then let's see how it does on the task, right? So we have question, my life can be measured in hours. I am served by being devoured. Thin, I am quick. Fat, I am slow. Wind is my foe. What am I? And it just pops out the right answer here. And same thing for this, just pops out the right answer. This is exactly the behavior we wanted. So that's pretty ideal. We're going to do the same thing now for the legal summarization task. So the idea here is that we have some long legal text that we wish to be summarized. And the idea is we train the model to provide a summary that is closer to this natural language, very curt summary than the more verbose summary it tends to give without this adjustment. So that's the idea here. That's what we're going to be focused on. So we have a legal summarization model and we have a riddle answering model. One is going to be giving short natural language casual descriptions of legal text, and one is going to be spitting out multiple choice answers to multiple choice riddles. And that is it. That is the thing that we're going to do. And so with that, I will pass it back to Greg, who will take us into the next section.
All right, thanks, Wiz. Yeah, so that was fine-tuning Llama 3. And as he just mentioned, we're going to fine-tune it again, and we'll provide this notebook as well. And the idea here is that legal jargon is stupid, and we should be able to build an AI that helps us make it less so. How about some simple language, like a real person? If you read something like, this, by way of example and not as a limitation, you agree that when using the services and content, you will not defame, abuse, harass, harm, stalk, threaten, or otherwise violate the legal rights, including the rights of privacy and publicity of others, lease the app or your account or collect or store any personally identifiable, blah, 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 blah. Okay, what are we talking about here? We're talking about don't be a jerk, don't hack or cheat. We don't have to ban you, but we can. We'll also cooperate with law enforcement. Thanks, Legal Easy. So what we did is we sort of built another Llama 3 model that can really help us streamline legal jargon, trained in exactly the same way, but on different data sets, on this plain English summarization of contracts. And that's going to allow us to merge Llama 3, fine-tuned, with Llama 3, same architecture, and a simple merge. We'll merge Riddlebot with Legal Easy. And what we're going to do is we're going to capture each task. So the big merge is all about multitask learning, fine-tuning an LLM for one, fine-tuning an LLM for another, merging those bad boys so they're good at both. Let's see how it works. Merging with mergekit and the new mergekit GUI. Wiz, let's send it back to you.
Okay, so this is the good stuff, right? So what we've done is we've taken the base Llama 3 8 billion instruct model, right, which has a bunch of weights associated with it. And we fine-tuned this model for two different tasks. One is this legal easy task, right? Just simple natural language summaries of legal, jargon. And this riddle bot, which is just going to spit out, A, B, C, D, or E to multiple choice riddle questions. Okay, makes sense, right? Each of these represent some update to the base weights of the model, right? So we've made changes to the weights in order to get it to do this, and the same is true here. So what we're going to do is we're going to head to the mergekit GUI. That's right. We don't even have to write code for this part if we don't want to. We technically have to write YAML, but YAML is totally fine, and it's set up in a way that makes it very easy to do. And the basic idea here is that because we're going to use this idea of ties as our merge, which, as Greg, let us know about earlier, right? The thing that ties is going to do is it's going to look at the base model. It's going to look at the task vectors from our fine-tuned models, and then it's going to take those into account when it's doing this trimming process and sign matching process. and then merge process. So what's basically going to happen here, right? And we can see this outlined in the YAML. We need to supply some models. So we're going to supply our base model. These are our base model, a pointer to the base model, basically. We want to supply our fine-tuned model. And you'll notice that we include some parameters here. We don't need to include any parameters for our base model since we're not going to do anything with it. It's just going to be there as a reference. But our actual model that we fine-tuned on this legal task or the summarization task, right? We want to use these parameters to indicate the amount that they're going to impact the eventual base model. So this is the idea of, we have hyperparameters that we can kind of tune while we're doing this process. And that might immediately make you think, well, what if there was a way that we could think about tuning these hyperparameters in a way that made sense and optimized for certain performance? And I mean, eval is coming in, right? So the idea is we're going to set these parameters, density and weight, to be equal for the two different models that we want to merge in. And we can think of these models, right, during the actual merge process. The actual thing we're taking from these models isn't like the whole, quote unquote, the whole model. It's the task vector from this model, right? So that it's an important consideration. The idea is that we are going to select both of these. We're going to use the merge method ties. We're going to indicate that this top model is our base model. We're not going to normalize. We are going to use an int8 mask, and we're going to make sure that the D type stays float 16. We have to provide our write token here, since we are going to be using both a gated model, and we want to write this to a repository so the model can be saved and used for later. And we're just going to name it Riddle Legal Easy. I'm not the most creative namer in town, so it is what it does, though. So there you go. This is it, right? So all we have to do is this YAML, and then provider token and make a repo name, and then we can click the big orange merge button. It's going to run through this merge process. It doesn't take very long at all. I believe it took about 4 or 5 minutes when I was running this, which is not long at all. You can see a detailed list of the actual merge configurations you can use. You can look at the different merge methods and how they're used. Very, very good GUI experience. Behind the scenes, this is just taking this YAML and running the script. So doing this through code or through script is also very straightforward, but I mean, the GUI just does the job. And as you can see, we don't need a ton of compute for this, right? This process is able to be executed on this space, no problems. Once we have our resultant model, which is going to be saved at this repository here, right? We can just move to a new notebook and see how it performs. So first of all, we're going to just indicate what merge config we use, so it's very clear what the resultant model came from. And then we are going to grab some dependencies, log in since we're going to be using a gated model. We're going to grab the original test sets for both of our tasks, as well as the original instruction templates. This is a rather important step since we did train them with these instruction templates. We do want to carry them forward. And then we are going to create prompts for them, just like we did before. None of this is new work, right? We've already done all this work, so we're just leveraging it again. So let's see how the baseline went, right? So we're going to try this base model in both these tasks. Again, it answers the riddle, but it's super verbose, right? It goes in a great detail describing why it's a candle. We just want it to tell us which option it is. For our summary baseline, again, we get, it's not bad, right? So this is our original text. This summary, though, is like not only longer, but it's also using less informal language, right? Proprietary rights notices, software development kit spelled all out. It's actually longer than the original text, right? So not a great summary. And of course, we have this, here's a human readable summary, additional text. Okay, it should be like this simple, right? So let's go ahead and free up the resources that we use to run the base model. And let's load our merged model. And remember, we fine-tune these two models in two completely different notebooks. All we did was we used this YAML file and we clicked merge, right? This is all we've done. That part took very little time and very little compute. And now we are going to see, you know, the result. So we're just going to load it the same way we loaded the other model to make sure it's fair. So still in 4-bit quantization, exactly the same loading process that we used before. We're going to make a new pipeline, but the pipeline's just going to be pointing at our merged model, easy peasy. So let's test this new merged model, right? Well, right away, we can see that it just spits out the answer exactly as we wanted it to. And we can see that you agree not to remove or alter any copyright or trademark notices that may be included in the software development kit. And that is, you know, technically a summary. And it is certainly more informal language than the original summary. And it is certainly closer to this ground truth summary, despite only training on 70 rows of data for 4 epochs, which took about a minute and a half for this task. But again, the idea is we now have this model that is better at both of these tasks that we fine-tuned separately. You know, and all we've done is merge it. And this, I think, is the key highlight for me, right? This process works. It is relatively effective. We've added capabilities to our model that it didn't have before through this merge process. And we done it in a way that didn't seem to negatively impact the performance of either halves of these tasks, which is incredible. And so that is the idea. That is what we want to do. That is, you know, why merging is impressive. And again, this is just using this ties merging. So absolutely incredible. I'm going to pass you guys back to Greg, but before I do, got to do the thing, right? So don't forget to like, subscribe, ring the bell. You know what I mean? I know it's we say it all the time, but we're here every Wednesday. Make sure you get notified if you want to keep coming, hanging out, and learning cool stuff. With that, I'll pass you guys back to Greg.
Yeah, awesome. Now, Wiz, I want to sort of jump in on this one idea, and if we can bring up the last slide that we were on. You know, I was confused about merging as we were sort of doing this and preparing for this. And I thought if we built a fine-tuned model that spoke in riddles, and we built a fine-tuned model that summarized legal jargon well, then we could like maybe summarize legal jargon in riddles. But that's actually not the case, right? That is not how we want to think about merging.
Yeah, I think you could probably come up with a convoluted example that might get you close to that. But I think more importantly, we want to think of it as adding new tasks or capabilities to our model, as opposed to like blending two personalities. Like, let's say we had a lawyer model and a riddle model. Like, if we merge those two models, the expectation wouldn't necessarily be that it spoke in law riddles, right? Like, the expectation might be that it's a little bit confused, that we're operating in the same kind of task space, right? Which is this behavioral or communication change. And I think the merging, as far as I understand it, and as far as I've used it, it really shines when you bring in these disparate tasks into the same model.
Love it. Okay. All right. Let's wrap up, and then we'll start Q&A here in just a second. Thanks, Wiz. So, you know, in conclusion, we can say combining 2 or more LLMs, that's what merging is all about. And really focusing on this multitask learning, this idea of task vectors, representing the difference between sort of what you tuned it for and what it was before you tuned it. This is really important to keep in mind. Same architecture, at least for now. Stay tuned. Algorithms include linear, SLERP, ties, which we saw today, evolutionary algorithms, which we saw come out yesterday, and we'll certainly be playing with on our end. I just want to shout out how legendary it was that Charles just saw that this thing didn't exist, so he built it. So shout out to Charles doing that 7 months ago. You see where it can get you guys that are out there watching, thinking about building something today. Keep building, shipping, and sharing, everybody. Follow Charles for some inspiration. You can find him on LinkedIn. You can find RC on LinkedIn and Twitter. With that, let's get into questions. We've got some great ones in the chat. Go ahead and use this QR code to add yours to Slido. Upvote your favorites. We're going to try to get to as many as we can in the next 10 minutes. Welcome back, Charles and Wiz. I want to start with this idea of of model zoos? I saw this question a little bit earlier and I really liked it from from Don Branson. And he asked specifically, could mergekit be used to create a new merge for Lava with Llama 2? And he sort of posted a model zoo. And I'd like to sort of direct this to Charles first. This idea of combining many different checkpoints or many different hyperparameter optimized different versions of LLMs. Is this something that, first of all, can be done and is done often these days?
Done often. It definitely can be done, and this particular use case, working with Lava, is something that I've been meaning to get to for uh, at least a month. It's very possible. It's just architectural change. It hasn't been implemented yet, but essentially, yeah, I want to make it so you can mix and match these Lava encoder image encoder models and put them on whatever your language model of choice is.
Okay, so you're saying if somebody were to help you start building, like, I don't know, Don Branson, this Lava stuff, you would be open to that kind of support. Very cool.
Absolutely.
All right, Don, you heard it here first, my man. Great question. Next, we'll go to Amin El Halou. Does it even make sense to merge Llama 2 and Llama 3, given that architectures are the same and Llama 3 was trained on more data generated and vetted than Llama 2? I believe this is supposed to read. Charles, let's go to you on this one again. What do you think?
Yeah, that's a good question. One of the earlier uses of model merging literature was sort of in the computer vision fields, and basically what they did was they would take some task, or you're detecting cats in pictures or whatever. They would train some convolutional neural network on it 4 or 5 different times with the same data, with different random seeds and different data orderings maybe, but it's the same data, same model architecture, and then they would just average all those together, and what you get out the other end is a model that's just strictly superior to all the models that went into it. It's better accuracy, better out of domain generalization. So we don't actually have a great comparison in the literature for something like Llama 2 versus Llama 3, where there's almost an order of magnitude difference in the amount of training data used, but it's still essentially the same task. So the hope there is that we might end up with basically just a better, Llama 3 plus Llama 2, conglomerate. But that's untested. Like I said, that's just the hope.
Okay, Wiz, do you have anything to add on this one?
No, I think that makes sense. I mean, the big deal is if we can merge the models, or let's say more importantly, if we can merge fine tunes of Llama 2 to Llama 3 in a way that makes sense, it could really accelerate, get Llama 3 to a place that we've spent a lot of time, resources, and GPU hours getting Llama 2 to. Not to use the word too many times there, but the idea is, if it can be done, it might accelerate us a little bit and catch us up as, like, say, Llama 4 comes out, or having that way to catch the new the new hardware up to the quote unquote, right? So we're not literally, but the new firmware up to the existing software might be useful in terms of our work being able to carry forward through models quicker. Yeah. But again, right now it's not possible, so it's strictly hypothetical. But that does seem useful.
I mean, like a question properly asked is half answered, and maybe this is. I mean, I would imagine that there's enough companies doing Llama 2 stuff right now in the enterprise that if you built this today, you could have a pretty quick startup and maybe even a quick exit too. That would be pretty cool. So, I mean, get after it. That'd be awesome. Shout out to AI by AI. Totally agree with you in the chat there. And Matul, thanks for joining us today. Super cool. More details about the evolutionary algorithm, please, Charles. Can you provide some?
I mean, there's an ocean of details there. So it follows pretty closely to Sakana AI's paper. So for the actual methodology there, reading that paper would be a great source there. Right now, the version that's released is only the parameter space merging, so it doesn't do it doesn't optimize Franken merges for you. That's coming. I just wanted to get this parameter space version out as quickly as possible so that people can start playing with it. I don't know if you have any specific questions on things it's good for, ways to use it. I'm not happy to answer anything about it.
Yeah. And it'll continue to evolve. So yeah, very cool. So check out that Sarkana paper as a starting point, and definitely start playing with the library because it just came out, and I know everybody'd love to see some hands get on that. So Anurag asks, Wiz, we can merge programmatically instead of the user interface, right?
Yes. Yeah. So if what you mean is we can use the script. We don't have to use the GUI.
Yeah. I mean, we saw the GUI today, and I was kind of doing the same thing. I was like, why should we even do the script if the GUI does the whole thing? I was like, it's kind of like, Charles, is there a reason to want to do the script instead of the GUI at this point? There wasn't one that I sort of came up with today.
I mean, the script is, I find it a little more convenient for running on my own hardware. And in case this is what you're asking, by the way, there is actually an API exposed as well from the library. So if you want to do something that's got merging happening in the loop, yeah, that's absolutely supported. That's the thing you can do.
Okay, cool. Yeah. I think the UI is just meant to make it a little more no code for people and make it a little more approachable. Okay, so Amin asks, so now the question is, given a base model for 2+ IFT data sets, something fine-tuning data sets on 2+ tasks, why not run one fine-tuning experiment on the data sets versus merge individual fine-tuned models? Wiz, are you tracking this? Charles, are you tracking this question? Okay, Charles, go ahead and give this a shot then. I'm not sure.
Sure. So the situation that happens more often than this is that you've got 2+ tasks that you want a model to be good at, and there are already 7 of them that have already been released and do those tasks. So instead of training on that whole combined data set of 10 tasks or whatever, you just take the ones that are new, train on that, and then merge it into the already existing models that do things that you want really, really well. When it's specifically the case you're talking about, where you have all the data and all the tasks, and there's nothing available in public, there's still a lot of value in being able to do these things separately, because it's not necessarily the case that the same hyperparameters are going to give you the best performance on all the tasks that you want to do. So it lets you sort of experiment with each of these domains separately, and then bring together the best of all of them in a single package without having to do some crazy factorial amount of training runs on different subsets of the data.
Okay. Instruction tuning. Okay, we were talking about this earlier. So that if you have a ton of different instruction fine-tuned models, then presumably if you merge them and they were all the same architecture, you just be better at following instructions in general, right? I mean,
that is the hope. Yeah. It's not always law. Test it before you run it, but that is the intuition. Yeah, and it seems to be the case in the available literature.
Okay.
There are some complications when you're dealing with models trained on different prompt formats, for example. But yeah, that's generally the case.
Okay. All right. Rabbit hole there. We're going to avoid it. And we might go a couple minutes over today just so we can get to a couple more of these questions.
I think too, if I could just add this a little bit, because I do think it's interesting what and worth double clicking in on for this specific question, right? So this idea that you're going to do a lot of experimentation anyway with these models, you're going to wind up with a bunch of different versions, right? And the thing that I most am excited by with model merging is, even with really naive merging techniques, you can kind of squeeze all the juice out of your different experiments, right? Which is something that is not traditionally something we've been able to do, right? We do an experiment, it doesn't work as well as we want, then we kind of leave it to the side, and then we repeat, and then we repeat, and then we repeat. I think in this case now we have a way to, get some value, however minuscule, if it exists, out of our quote unquote failed experiments, which is something that's, again, it just helps us increase the amount of effectiveness we get for each dollar, for each GPU compute hour, right? Even if it's a tiny improvement from a failed experiment, it's still, you're getting non-zero value, and that's worth, the fact that model merging costs very little, both in time and compute, right? So
yeah. Yeah, you had me thinking about this in terms of like the re-ranker in a RAG system. You're sort of returning the top piece of context, but also the other ones, and you're order ranking them. And so if you did a ton of hyperparameter optimizations and you sort of order ranked how good they were, you could leverage like the top K of your hyperparameter tuned models and pretty cheaply and just see if it actually produces better generations, right? Similar to the whole RAG idea. Yeah, it's such an interesting space, this model merging thing. So I want to kind of go to, let's end on a kind of a bigger question here. Deep Learning Partnership asks in the YouTube chat here, what does the merge roadmap look like, Charles? I think this is a great place to end. What is the future of merging, according to you and RCAI at this point in 2024?
Sure. So, there are always new merge methods coming out. I'm continually like watching for those and integrating them as they come out. In terms of, what my main research direction though is right now, it's on cross-architecture merging. So I really want to enable that use case of, you've tuned on some model and then there's an entirely new base model that you want to transition to. Just take that training that you've done and port it directly over to that new model. That's where basically most of my research focus is going. And there are, there are small, increments along the way to that you probably see come out in roughly this order. Merging between, for example, like Llama 2 and Llama 3 is going to be one of the easier things to do because they are essentially the same architecture. They were just, trained from a different starting point. The really, the crazy thing that I want to get to is take an example like merging a Llama 7 billion parameter model with a 70 billion parameter model. I have a bunch of ideas for how to enable that. Some of them are looking quite promising right now, but imagine, because you can do a full fine tune on a Llama 7B model for in the scheme of training, essentially free. And if you're then able to merge that in with a 70 billion parameter model and get that incredible, general reasoning, that's something that I really want to enable.
Yeah. How about that 400 billion, right? Yeah, like
Exactly.
yeah. Well, that is a fantastic place to wrap up. Charles, can we share your contact info with the audience here? People are asking to
Absolutely,
get in
yeah.
touch with you, and you'll be carrying the torch on merging in the
Yep.
industry moving forward. Love to hear it. We look forward to having you back when the next big release comes out, man. It's been
It
a
sounds
pleasure.
great, and thanks so much for having me on.
Absolutely, man. Thanks, Charles. Thanks, Wiz. It's time to rock it and close out. Thanks, everybody, for joining us today. If you liked that, check out our Discord community. If you haven't joined it, it's a great place to nerd out on things like model merging and share your latest build. And if you're interested in starting to really accelerate your learning up to the open source edge, check out either our open source course from last year on LLM ops, or check out our most recent and most up-to-date AI engineering bootcamp. It's an 8-week course. The next cohort starts next month in about 30 days. And if you have any questions about any of the content or materials that you've seen from us, don't hesitate to reach out to me personally or to Chris personally on LinkedIn or directly via YouTube. Finally, if you have feedback on today's event, we'd love to hear it. As always, whether it's directly in the form we provide or through the Llama follow-up email, and let us know what you'd like to see next as we all continue to build, ship, and share out on the edge. Until next time, we'll keep building, shipping, and sharing. We hope to see you do the same. See you next Wednesday, everybody. Have a great week.